All right, welcome back from the break. Remember, we are still on this revision series for students that are preparing for the NECO SSC, WASI, and UTME. So that's revision series for WASI, NECO SSC, and UTME candidates. And we are still on physics meal, and the topic we have been looking at is elasticity of materials. We have said a few things already as far as elasticity of material is concerned. We have looked at the meaning of elasticity. We also considered the Hooke's law, and then we decided to say a few things on force constants, or what we call elastic constants. So quickly, we are going to look at basic mathematical expressions that we may need. So basic expressions for calculation. So basic expressions for calculation. As far as elasticity of materials is concerned. Now, we have to see one or two expressions that will be very, very important in our calculations. Now, let's recall. Remember that we have said that F is equal to KE. That's our equation 1A. You remember that? Now, if F is K, it means that K is F over what? E. That's our equation 1B. They are still on the board anyway. That's this and that. Okay? Now, for a given material, or a given substance, or a given body, K is constant. For a given body, K is constant. So if you have a particular spiral spring, or a particular elastic body, for example, the K, no matter the load you use here, no matter the force you use here, even if it's a force of 100 Newton that you use, and later you change it to 50, the K obtained when using 100 will be the same thing as K obtained when using 50 or when using 20. So we have to say this now. If I use F1, the K will be the same thing. The K1, if I use F2, I will obtain K2. But since the bodies are the same, K1 will be equal to what? K2. That's what we are trying to say. That K1 is equal to K2. So if F1, right, produce extension E1 and force F2 produce an extension E2, then it means that K1 will be equal to F1 over E1, and then K2 will be equal to what? F2 over E1, E2. That's what it means. For this particular force, we have extension this. So its force constant is what? K2. And the force constant for the first one will be K1. But remember, it's a constant for a given body. So since K is constant for a given body, since K is constant for a given body, then we can comfortably write then K1 is equal to K2 because it's what? It's a constant for a given body. Because of that, we can say that F1 over E1 is equal to what? F2 over E2. That should be our equation 2. It's because K1 is F1 over E1, K2 is F2 over E2. So if K1 is equal to FK2, then we can use this to replace that, then we have this. So we can move on also. That's another expression. So we have this equation 1A and 1B, and we now have equation 2. So when we are given two different forces, and maybe one extension, we can find the next extension. We're giving the force and its extension and another extension, but we don't know the force. We can use this to actually calculate the force. Okay. Now, again, if L is the original length, and L1 is the final length after application, okay, it's the final length when a force F1 is applied. Then it means that E1 will be L minus L1. So extension should be the final length minus the original length. Sorry, L1 minus L. Because we have said L is the original length, L1 is the final length when the force F1 is applied. So the extension is final length minus original length. So if I have a spiral spring like this, let's illustrate this. If I have a spiral spring of this nature, and let's say I have a meter, and this is actually indicating this is the original length, for example. And when we apply the force, we have this. Let's say there's a meter here that gives us the original L, and then after application of force, this extended to this. We have another meter that gave us L1. So the extension now, by applying a load, a force F1 now, this no load is here. So with the original length of this, when you applied a load, we'll see a practical section of this in our next class for us to actually illustrate this in reality. So when you apply a load, this will extend to a new length L1. So that extension E1 will be the final length minus the what? Original length. And that's what we have here. So similarly, if L2 is the length when the force F2 is applied, then we can now say that E2 is equal to what? L2 minus L. Let me call this 3A. And let me call this 3B. Beautiful. So if I now applied another force that is different from F1, I will have a new length. To find the extension as a result of the new length, I use the final length minus the original length. Now you see, E2 is this, E1 is this. I can use equation 3A and 3B on equation 2. I can substitute equation 3A and 3B into equation 2. And if I do that, in place of each one, I can write what? L1 minus what? L2. So substituting, mind me, I need to make this clearer. So substituting equations 3A and 3B into 2, we're going to have what? F1 now over what? L1 minus L equals F2 all upon L2 minus L. Let me call this equation 4. Another beautiful equation. So take note of all these expressions because they are necessary. Now, before we actually leave this aspect of elasticity to now look at the graph of force against extension, and then we now begin to look at work done in an elastic material after we have considered the components of the graph. Let's make one more important statement and generate an expression from there. Now, it's not all the time that we may be giving force directly. The force can be given, so I can say note, the force can be given as a load or what? Or weight. The force can be given as load or what? Or weight. You can give the force as load or weight. You can give it as load or weight. So, if I use a weight, slotted masses that you use in your physics lab, you have a weight. You know, some of them are usually circular in nature, spherical or cylindrical in nature, circular in nature or cylindrical. They are thick, so we're going to use the word cylindrical, although they have some opening for you to slot them. So if we use this, we'll be talking about weights now. Weight. So we can actually, in place of force, use what? Weight. Use weight and load. Now this load can be in form of weight directly, or they may be in form of mass, which you need to convert to what? To weight. Now remember that weight of a body, weight is mass times what? Acceleration due to gravity. And weight is a form of force. It's a form of force. So if weight is W, you can write this as mg. So if we now use weight in place of maybe force, they did not give us force directly. They may give us mass, or they use the word weight. Remember, weight is force. If we use weight, that means W1, weight 1 that we produce a given extension is going to be M1G. You know, G is a constant. Then W2 will give us M2 and the word G. G is also a constant. So in place of force, if weight is given, in place of force, we'll now be saying that F1 will now be W1, and F2, which will produce extension 2, will be W2. Now, in place of this force in these equations, now we can now write equation 2. Equation 2 can now be written as W1 over E1 plus W2 over what? E2. We can call it equation 4 now, because we have 4 already, equation 5. I can still bring it to this place, to equation 4. So I can still write it as W1 over what? L1 minus L plus W2 over L2 minus L. And call this equation 5A, this one 5B. Let's use that they are similar. They are similar. If weights are used. Now these weights, we can also substitute M1G for them, and then we generate other expressions. Very, very important. So if I want, I can go further to say, since W1 is M1G, I can write it as M1G all upon E1, and then M2G all upon what? E2. G is a constant, so it's the same here. If you divide both sides by G, you will have M1 over E1 over to M2 over E2. Do you see how I'm playing around with all this? You can also do the same. You have all these expressions with you. And if you do the same for this one now, you still have M1G over L1 minus L equals to M2G all upon L2 minus L. And then that means G is common there. If you divide both sides by G, divide by G, divide by G, you are mathematical students, I know. You cancel out G, you'll be left with M2 over L1 minus L equals to M1, M2 over L2 minus L. So I can actually give these equations name. This one as equation 6A, and this one has equation 60. Wow, that's beautiful enough. That's beautiful enough. These expressions, they are basic expressions that we need to do some calculations. We still have other expressions, as you know. You have done this topic before. We are just trying to actually refresh ourselves on this. And you know, you still have stress and strain, and then Young modulus. That's tensile stress and tensile strain. Then we still have expression for Young modulus. We still also have expression for work done in an elastic material. But for now, let's write the expressions that we're going to need so far. Let's quickly put down these expressions quickly. What are the expressions that we have actually generated? Or one, we have also said that F is equal to KE. And from there we have that K is F over what? E. Once you remember this, you know this, so no need of trying to remember this one. Okay, we say that F1 over E1 is equal to F2 over E2. That's one equation again. They all have equation number. This is just the serial number, not the equation number. You can put the equation number by the side as you're writing them. We also say that F1 over LO1 minus L is equal to F2 over LO2 minus L. Okay, we knew how we obtained this. We're going to write that E1 is actually L1 minus L, and E2 is actually L2 minus L. Okay, let's go further somewhere here to talk about the weight. We already weight, we know it's MOG. We have established that. So we say if weights are given, now write W1 over E1 is equal to W2 over E2. W1 over L1 minus L equals W2 over L2 minus L. Then we also established that since weight is MOG, we can write this as M1 over L1 minus L plus M2 over L2 minus L, or M1 all upon what? E1 is equal to M2 over E2. Now we know that we usually consider standard unit, that's the SI unit. So when we begin to do calculations, we're going to see that. So these are the equations we have generated so far. They are not many. They are things that we can actually remember. Yes, now. Some of us, we cram a lot of songs. Now, all the songs, all the African musicians, you have their songs inside your head. You enjoy singing them, nodding your head. You can also enjoy singing these ones, nodding your head. Even as you sit down in your house, you can just be discussing this with your father. You can discuss it with your mother. You can also discuss it with your friends. You can just tell your father that F is equal to KE, where F is the force producing the extension, E is the extension, and K is the force constant. You can also tell your father also that F1 over E1 is equal to F2 over E2. You can greet your mother good morning by telling him that F1 over L1 minus L is equal to F2 over L2 minus L. Don't mind me. We're going to go for another break. And when we return, we are going to look at the graph of Hooke's law. That's the force extension graph. And when we look at that graph, remember we say that we are going to revisit elastic limit. There are other things that we'll talk about from the graph. We're going to see elastic limit again in that graph. And from there, we'll now explain elastic limit, what we call the yield point, what we call the maximum load, what we call the breaking point, and the proportional limit. Don't go too far, because we need to finish up this elasticity and move to another topic. There are so many topics that are yet to be touched as far as physics is concerned, and we must make sure that we cover as many as possible before you enter the exam hall to write this year's physics. Bring it in your UTME or NECO SSE or your WASI. God bless you as you continue to follow us. Make sure you follow us on Facebook at Science Tutorial and also Mathematics Meal. Make sure also that you follow us on YouTube at Mathematics Meal 1 and also Science Tutorial. And as you do that, you will continue to enjoy our delicious meal on physics meal, chemistry meal, biology meal, and more especially the mathematics meal. Thank you and remain blessed. I'm still your humble servant and your humble teacher, your humble reminder Engineer I.